I'll tell you a little bit about me, and then I'll tell you a little bit about the talk. So I am the CISO at Data Gravity, based in Nashua, New Hampshire. I actually live in California because they asked me if I wanted to move to Nashua in the dead of winter. And I said, I'm Canadian, I've had enough snow the first half of my life, I'm good. I used to run the research team at OpenDNS. I was the Director of Research and Chief Evangelist at Cloud Passage. I've also been a in the trenches practitioner, worked for a university in Western Canada at a bank in Bermuda, which sounds a lot cooler than it actually was. Also worked at Q1 Labs doing product engineering management. I've also written a whole bunch of books that, based on the statements they sent me, none of you have read, which is fine. I blog somewhat occasionally. And I spend a lot of time on planes because, as you can tell, I am built for coach. So this is what we're going to talk about today. I'm going to go over a little bit of the background as to why this talk's important, why I'm even giving it. I'm going to talk about how you should start your security research project, some of the ideas, how you can refine them, how to get started, knowing when to stop. Knowing how to start and knowing when to stop are equally as important. How to present and defend your research, and then I'll wrap it all up and we'll ask questions. So why me? So I've built engineering teams, research engineering teams. I actually had someone stop me at the RSA conference and say, hey, you're Andrew, hey, you're the Hello Barbie guy, which is awesome. That's what you want to be referred to as, is the Hello Barbie guy. So if you're going to research something cool that doesn't sound as lame as, oh, you're the Hello Barbie guy. But yeah, done a lot of presentations, presented research all around the world, still actively doing research. It's a great hobby. I'll get to that in a bit. So is anyone here an academic, aside from Tim? Former academic, recovering academic? If you've done any pure science, you've probably seen this before, and this is Pasteur's Quadrant. So what we see quite a lot of is in the top left-hand corner, you get a lot of pure basic research, which I really define as, you're doing a lot of thought leadership. You're not releasing tools, you're implementing ideas or releasing ideas that you expect others to take and run with and build tools around. Nothing wrong with that, a lot of great ideas came out of that. Pure applied research. So I put Dave in this section because he's not building picks to give back to the lock community or the lock manufacturer, say, here, build your lock better. It's purely applying the knowledge that is learned from breaking the locks and sharing that with the community, which, again, great idea. Who doesn't like lockpicking? And then there is this kind of hybrid, the use-inspired basic research, where you're taking ideas, but you're also releasing tools. And this is really the area that I find that a lot of security research gravitates to, or should gravitate to. Another way of looking at this is if you cut it down the middle, or diagonally, and you have the knowledge up on the top left, and then how useful is the actual application of the knowledge, the bottom right. So again, top right-hand corner, probably where you want to be. So this, and I apologize if you can't read this, a little fuzzy, but I found this chart, and the link is at the bottom, but it talks about the different things that a data scientist should have. So I've had a bunch of data scientists work for me in the past, and a lot of these are true, but I find that a lot of the core profile elements here also pop up in security research as well. So math and statistics, I'm really crappy at math, so that's not me. Domain knowledge and soft skills, that's probably more my wheelhouse. Programming and database, Communication and visualization, yeah, hey look, PowerPoint. Woo. I'm also not a woman, so of the 5 things, I am 3 of these. But what's missing from pure data science, where you're sitting there either discovering new data or taking existing data and putting it through its paces to try and shake out ideas. I find that security research is a lot more of curiosity-based research, or I wonder what this new product that was released can do, or what I can make it do. So that's another event action driven. So for example, the Hello Barbie thing. Hello Barbie came out, and I'm like, hey, I bet you that has some security issues around it. Definitely has some privacy issues around it. So let's take a look. Then there's also go-to-market time sensitivity. So if you find something like an exploit or whatever, some sort of vulnerability in a device, application, your toaster, whatever, you probably want to get that out first. So there is that time sensitivity aspect that pure research doesn't really have, because as I was talking with Tim this morning, if you get a grant, you're just kind of cruising through till the end of that grant. In academia, you can figure out you can prove your hypothesis over the duration of your grant or your tenure. Doesn't really happen in the security research world. It's a very Ricky Bobby type of you're either first or last scenario. And there's that inherent need to do good or bad. I won't say that all security researchers are good. A lot of them play in that fuzzy good-bad area, and then some people are just bad. Although you're probably not going to see a lot of bad guys release their research to help the community. Like, hey, here's this massive botnet that I created that I've made hundreds of millions of dollars on. Now you can too. Here, take it for free. Go run with it. That doesn't usually happen unless they're done with it. So if you're deciding that you want to research something, and has anyone here ever thought, hey, I want to research something. I want to come up on stage and talk. I want to sit in the front row. No. These are some of the types of research you can do, or broad level concepts. So you can do net new research, which I love doing. Net new research is fun. You get full control over the experiment. You can be first, potentially, to get your proof released. It is very time consuming though. So I will admit to spending about an hour and a half during work time surfing for the purchase of a Barbie, that if anyone was looking at the proxy logs would have really been wondering why Andrew was spending so much time looking for Barbie dolls that talk, considering I don't have kids. It's a little creepy. It's research, I swear. So yeah, it's very time consuming. There is that aspect of time sensitivity, because the day that Hello Barbie was released, I know at least 5 other researchers that had already pre-ordered, just like me, and they were just waiting for the thing to be delivered. Continuing someone else's research, also fun, less overhead. You have the data provided it's being shared with you, and you can find new results, or you can refine what has already been found. The downside of that, however, is the breaking findings are already known, so you're not, there's less potential for you to shake the world up. And you don't really have a lot of control over the experiment, because if you're working with previous data or previous research, you have that constraint of this is what was done before. You could deviate from that, but ultimately you're going to be using the same methodology and steps A through Z to get there with a couple deviations. You can challenge someone else's research, which is fun. There's not as much time sensitivity. You can take as long as you want to do it. You can disprove someone else, and this doesn't mean calling someone out on Twitter. That is not challenging someone else's research. It can be very time consuming, because you could be spending an awful lot of time begging and trying to borrow the data from the original researcher. And really, if you're putting a foot forward and saying, hey, I believe your research is absolute garbage, can you share the data with me? I want to disprove that. Probably not going to help you out too much. It could result in no new results. You could have spent all this time helping prove that research. So you're not challenging it, you're coming up with the exact same findings, which I'll get to a little bit later. Coming up with the same findings or coming up with no results, negative results are still results. It's just a negative finding. Yay, research. So if you are going to research something, or if you want to research something, always ask yourself these three questions. What is the question you're trying to answer? I'll give you an example for the Hello Barbie. I wanted to know if Hello Barbie was, if there were privacy risks. And does anyone here not know what Hello Barbie is, by the way? Any other men here without kids? So Hello Barbie is an IoT doll that when you press the button on her belt, again, a little creepy, the belt buckle, your kid can talk to Barbie. All the information all of the questions and interactions are uploaded to the Toy Talk cloud, which owns the software. They run analytics to determine how to answer your child and then send that response back, and Barbie interacts with you. So as soon as I found that out, I'm like, ooh, there's some privacy issues there. There has to be, and likely some security issues because they want to be the first to market with it. So I wanted to know if there were privacy and security issues around this doll. Surprised there were. Do you have the data to answer the question? Why, yes. I spent an hour and a half buying Barbie. And I was waiting. I made the mistake of having it delivered to work. So not only did I spend an hour and some searching for this thing, but then I had Barbie delivered. And everyone was really excited that it arrived because I told a bunch of people, but then some of the marketing people were walking by and like, why the hell is Andrew playing with a Barbie at work? San Francisco. You can't ask those kind of questions. So do I have the data? At the time, I didn't have the data, but I had the means to generate the data. So ultimately, I did have the data that I needed. And if you could answer the question, could you use the answer? So personally, I was able to use the answer. I was also providing an answer to the millions of parents that were buying this thing for their kid for Christmas, Hanukkah, birthdays, whatever, Arbor Day. I thought that it was usable. So the answer to 1, 2, and 3 were yes. So ask yourself this question. Like, let's do an example. What's a question you're trying to answer? Does my toaster have internet? Do you have the data? I have a toaster. It's not connected to the internet. Crap. All right, so I can't do 2. If you could answer the question, could you use the answer? Well, I can't answer the question, so that's not a research topic. Simple. I won't go over all of these in detail, but these are the different types of questions that you can ask. This is very pure research oriented. I do find that a lot of questions, a lot of the hypotheses that you're posing when you're doing security research typically fall into the exploratory or more exploratory and inferential. So you're looking for your findings, or you're looking for something to shake out of the findings, or you're making that inference that you believe that X is going to be equal to 5, and then throughout the course of your investigation or your research, turns out, hey, it's 5. You inferred that. Woo. Then there's this isn't all just charts, by the way. This is some of the data analysis techniques and tactics you should follow. So you have to set the expectations. You're starting there by, here's what I expect to see. Hello Barbie communicates with the Toy Talk cloud not using SSL, for example. So then collecting information, I'll start looking at packet captures. Funny, it's all SSL. So now I'm going to revise what I'm saying. Like, okay, well, if it's using SSL, maybe I should say, hey, you know what, maybe this is using insecure protocol suites or cipher suites. And you go back. So now my hypothesis, or part of the hypothesis is, I believe that Hello Barbie is
Hi folks, I'm Geek here. Unfortunately, we had a problem yet again with the Avid Media freezing up. I really need to think of something to do to replace those. So we have no audio until about the 27-minute, 30-second mark. Sorry for the inconvenience, and it happens one more time in this video. So my apologies to Andrew.
Device network research, again, you're plugging it in. You're probably going to want to have 2 network access points with a span, tap, whatever in the middle, so you can see the traffic as it crosses, unless you have your own homegrown or hacked wireless base station that you can actually do the packet captures on. I find it easier to do this way because you don't have competing traffic. You can isolate just the one IP. Personal preference. You also want to see what cloud hosting or external sites it's communicating with. For example, does anyone here have a Samsung Smart TV at home? Fewer and fewer people put their hands up when I ask that. So the Samsung Smart TV, during the initial setup, actually phones to Korea. It's all right, though. It's going to South Korea. It's going to the friendly Korea, so don't worry about it. But that's not something that you would expect unless you do a little research. And actually, the beaconing home to that Korean server is actually a piece of software that is no longer supported, but they just didn't remove it. So it's in the TVs, and it still beacons out like crazy every minute or something, sending analytics up. So that's a finding that you want to note. Software, again, you can start decompiling, reversing the software, run it through a debugger, see what you can get out of that. Again, if you have software expertise, this is going to be more important to you than the network side. You can get a whole bunch of domains, IP addresses, URLs that you may not see in your research, but they're stored within the code base. So you may not be hitting a specific condition that would generate traffic to those domains, IPs, whatever. That's interesting to note. And that's how you find software that shouldn't be in there anymore. Hardware, not an expert in hardware, but keep in mind that when you are looking at a device, so a physical device, you should also look at what type of information is being written to your workstation, to your mobile devices, based on that software. You could find a lot of information that is stored that shouldn't be there. So for the Hello Barbie stuff, for example, they had self-signed cert on every single Barbie with a hard-coded password, and it was the same cert and password for every Barbie so that it could do the initial setup. It's not the fact that it's self-signed, and the password was just obfuscated. It wasn't encrypted or anything, because it's easier. Security's hard. Here's some suggested equipment applications. For the hardware side of things, I'll direct you to a really great slide deck. Who did that? Mudge. That's Mudge's slide deck from Black Hat a couple years ago. 2014, I believe? Yeah, 2014, where he lists all of the tools that you need to hack hardware. It can get very expensive, like an oscilloscope. You could probably get one at a garage sale, maybe. But they're not cheap. So like I said, knowing when to stop is just as important as knowing how to start. So these are the 4 areas that I found that you will stop research. So 1, there's artificial or organic time constraints, such as marketing saying, hey, you know what? We need new research to publish, and this does happen. We need new research to publish for this quarter, so you need to get it to us halfway through the quarter, and then 15 days before that, so we can spin up the marketing machine and blah, blah, blah. So you're saying I've got a month to research this. Oh yeah, well, you know, I'm halfway through this month already. Well, it seems like you know how to do math, so there's only a couple weeks that you have. This does happen all the time. So you have to constrain your research to fit into the scope. That doesn't mean that you can't carry it on after the fact and do additional research, but this is just the initial research that has time constraints associated with it. There's also the idea of the diminished relevancy. So maybe someone has proved or disproved the hypothesis. Maybe the device was taken off the shelf and nobody uses it anymore at all. That happens. Should you publish your research? You can. Will it be as big a bang or as meaningful? Probably not. It might be. And then success, hey, you've proven your hypothesis, you can release your research, you can stop now. Failure, again, you can stop, and failing is not bad. Because if you're looking at failure, you know what, I'll get to that in a second. So you have to really set the definition of what you mean when you say successful research. I will be done because this will be completed. I will prove my hypothesis. You know, everything is awesome. Play the stupid song. That's cool. But just because you've done your research doesn't mean that you've shared it. You need to start looking at how can I communicate my findings. Do I share it in a presentation, a blog post, a white paper, webinar? Has my findings influenced policy, whether public or private, or just organizational? Has something positive happened as a result of my doing this research? And then, you know, sometimes success is that the data that I have is not sufficient to answer the question that I posed. In which case, you go through that 3 models. Okay, I'm going to refine the question that I'm asking, and I'm going to see if I can get some research out of this and get more data. What else do I need? That's where a lot of people get stuck, I find, is they just saying, I need more data, more data, more data. I need to connect to Shodan. I need to connect to virus total. I need to do this. I need to write code. Maybe you need to do that, but again, unless you're in academia, you don't have that huge buffer of time. There could be artificial constraints imposed upon you to release your research. So again, I guess I alluded to a couple times, failure is not necessarily bad. On one hand, you could be a cautionary tale to others as to why you shouldn't research this way. A negative outcome is still validation that the way you researched or the data available wasn't sufficient to answer the question you posed, or maybe it wasn't the right question to ask. I know it sounds it almost sounds like lawyer speak, where you're just kind of working with the words to craft the answer. You know, this uncertainty that you're putting forward, say, hey, you know, I published my research, I couldn't answer the question. Maybe someone can point at that and say, hey, you know what, I think you did something wrong here. So if we run with that data and, you know, just tweak the experiment a bit, we'll get a different answer, and maybe then we can have a successful outcome, or a more positive, a non-negative outcome. Now, presenting your research, who here hates public speaking or presenting? Wow, everyone likes public speaking? Yeah, kinda, maybe, sorta. Under your own constraints. So this is a very common research pipeline model. It's very academic. You don't necessarily need to follow this, but what I would say is that when you get to the results phase, actually when you get to the code phase, if it's required, and you get to the results phase, you can publish your results in any of these forms. And I'll go into it in a little bit more detail. And don't think that you have to write like a PhD dissertation style research paper. You'll probably hate yourself and never want to research again. There's only so much Dancing with the Stars on TV and time to do that. So you could simply just write a blog of your findings, publish your research, publish your code, and say, hey, you know what, this is what I found, this is what I asked, here's what I proved. That's a great model. You can publish an article, whether it's a popular print, online trade rag, whatever. This generates, when you publish articles, you will in all likelihood get people reaching out asking for more information or challenging your research. You could release an academic paper. Again, if that's the type of audience that your research caters to, by all means. Don't do an academic paper just because you think you have to. If you are a reverse engineer, you probably don't have to do a research paper every time you reverse something. You can do a blog post. Much more impactful. White paper, marketing loves white papers. So if you can create research that will fit into a consumable white paper form that their sales team or your sales team can take and leave behind at an organization, that's great. They will love you. And it's also very consumable for media because they will send that off to the reporter and say, hey, do you want to talk to our researcher that has done XYZ? Charts. When I say charts, I don't mean pie charts. I'm talking about actual charts that show meaningful information. If you've not seen raw before, so does everyone here know what D3 is, at least in concept, from a JavaScript visualization platform engine? I'll say engine. So raw takes the coding aspect out. You can upload your CSV, TSV files to raw and then select like bubble charts and all the really sexy charts that aren't pie charts. You can use Tableau Public. It's free. Plus, it gives you a really good way to publish your research. You can point people to a page where they can interact with the data. Open Graffiti. So when I was at OpenDNS, Thibaut, who worked on my team, he created this. So that's a 3D immersive semantic network graph that you can actually get like an Oculus Rift and zip through. So there, you now just have justification to buy an Oculus Rift for work, for data visualization. And then graphics and pictures. Infographics, just a word on infographics, or, you know,
And this is the second freeze. Audio should resume at about the 42-minute, 42-second mark, thereabouts. Sorry for the inconvenience.
talked to in the DFIR community was like, that's awesome. Too bad it's in Ruby. I'll never use it. Great. Well, do you want to rewrite it in Python? No, but you should. Okay. So know your audience that you're releasing to. If they want everything in Python, just do it in Python. Jupyter Notebook, great way to release research that is, I know it's a little fuzzy, but you can actually have a page that shows the code runs and the results as you go through. Very cool to check out, and it supports a whole bunch of different languages and kernels. And GitHub. Who hasn't heard of GitHub yet? No smart ass put their hand up. Awesome. Publish your code. Let other people refine it. Publish your data if you're allowed to. That's the big thing, is if you can publish your code, cool. Publish your source data as well. Even better. In concert, I'll get to that in a minute here. So when you're writing your code, make sure that you are writing good code, which is hard for me because I'm not a programmer. I write code. I'm a hacker in the sense of the word that I'm a hack, in that I hack and slash until I get the damn thing working enough that it is at least reproducible once or twice. If you're writing code, you are collaborating with your future self. I can't tell you the number of times I've gone back to my code and said, what was I thinking? Why do I have like nested functions within functions pointing to this file that doesn't exist? I have no idea. Because as we all know, developers, awesome at documentation. I'm really bad at that too. You don't have to be a developer to be bad at documentation. There's the soundbite for the whole conference. So make sure that you can go back to stuff. So you, at some point, if you're releasing research, someone is going to call you out. You will have to defend your research. Your findings will get challenged by a number of cute icon disturbers, heads, and grandstanders. Some people just want to watch the world burn. So if you publish something that they don't agree with, they'll just say, that's garbage. You're wrong. So what you do is you point them to the tools that you developed, the data that you used, and your findings. Say, all right, prove me wrong. 95% of the time, these people will back down and say, oh, well, you're wrong. You're wrong. I don't have time to test this. Like, well, if you don't have time to test it, I don't have time to argue. I'm going to move on. If you give them the tools and the data to validate or disprove your hypothesis and your findings, you've done all you can. The world will see that, and you will not become a charlatan. Unless for some other reason. But that's a very good way to not end up on a charlatan list. Plus, you can also take the higher road and say, look, here's my data, here's my tools. I'd love for you to go see if you can reproduce my findings, or maybe even make it better. If it's someone helpful that's not just trying to grandstand and point at people and say they're wrong, they may help you. And that collaboration actually works well in the long run. Really, some people are just jealous. You will encounter this because the security industry is a big schoolyard. I would say a dance, but everyone's standing on the wall. So that analogy doesn't work. But it's a schoolyard. There's cliques. There's people who just want what others have. They want the fame that others have. They wish they had released the results, or they were doing the same research. You released it first, so they're just pissed off. It happens. Get it? So Roger Peng, who's a researcher, teaches a lot of R and statistics courses at the university I can never remember. He does all the R courses on Coursera that are pretty cool. So ask yourself these questions if you're identifying if your research is valid and if you're following good processes and procedures. So are we doing good science? Yes or no? Was any of this done by hand? Yes. Okay. Did we document it accordingly? Does the documentation match reality? Have we taught a computer to do as much as possible? I.e., have we coded anything? Are we using versioning control system? The answer should always be yes. Have we documented our software environment? The answer should always be yes. How far back in the analysis pipeline can we go before our results are no longer automatically reproducible? That's good to know. Have we saved any output that we cannot reconstruct from original data or code? Maybe. How do we validate that? Now, responsible disclosure, I encourage everyone to follow responsible disclosure. This does not mean I put it out on Twitter and GE Healthcare didn't respond, so I'm going to publish it 3 hours after I responsibly disclosed this. This is reaching out, email, Twitter, phone, making a best effort to get in contact with the people that you're responsible for the device or the software that you're researching. This worked really well with Hello Barbie. So the Toy Talk guys, we were lucky enough that the company that I went to after OpenDNS, Data Gravity, we shared an investor with Toy Talk. So I went to that investor and said, hey, can you introduce me to someone technical over there? And he introduced me directly to the CTO. All right, cool. Can't get much higher than that. Told him that we had some findings we wanted to responsibly disclose, and he's like, well, let's set up a call. So we went through all the information that we found, told him about all the glaring issues, and he's like, okay, this is great, let me digest this, I'll get a couple more technical people on the team involved, and we'll see what we can do. And then like a day later or something, we had another phone call with him and his team, and he had an action plan of how things were going to be resolved. And really a timeline of when they would be resolved by. And he kept asking, when do you need to release your research? Which I thought was cool, that he cared that I had a timeline. Thank you. But he wasn't saying, you can't release it until X. He's asking me, when can we release it? So, we worked together on this bug bounty sort of thing. They did not have a formal bug bounty at that point. They were rolling one out. As a result, they thought the findings were pretty significant, and they awarded Andrew Blach, my co-researcher, they gave him 10 grand for the finding. Not bad for a couple hours work over a couple weeks, 10 grand. Because of my tax situation. As a Canadian, I didn't want to deal with all those taxes, so I'm like, you just take it, I don't want it. So sometimes you're not going to get a response. You won't get that friendly a response. Other times you will. Sometimes you will get a negative response, which will be followed by legal action, cease and desist orders, and name calling. That's fine. Go to the EFF. Know your rights. Use your judgment on time to publish. Don't feel that you have to be constrained to what they want you to do. Work with them to disclose it responsibly. So hopefully through this, it's resonated with you a bit so that you know that anyone can do research. You can go do research. Again, find a show that your significant other loves and you hate. There's your research time. Establish your own process and your own cadence. Again, if you only have 2 hours a week to do this research, then you should be able to project how long it's going to take you to research the hottest new IoT device or a new piece of software that comes. This will come with experience and time. Just make sure you document it so it's repeatable. And maybe you can involve others to help take some of the load off. Disclose responsibly, and you have to know that people are going to challenge your research, whether it's constructive or not. Most times it's not going to be constructive. Be prepared and be an adult on how you respond. That's the words I can give you there. So some further reading and training. The executive data science, so if you're a manager, if you want to know a high-level process on how research should happen from a data science slant, check out that Coursera link. The data science, so I've learned a lot of R for my sins. That Coursera course, really good, teaches you how to think statistically. Oh, come on in. Yeah, you're just getting the summary. I'm sure you'll have lots of questions. Course materials, you can just get the course materials here if you don't want to take the course. A lot of software though, and a lot of labs that'll help you go through the courseware. Codecademy, yay, it's how I learned Python and Ruby. That and a lot of swearing. Here's some books. I own every single one of these books. If you're doing any sort of network-based research or incident response, IDS development, make sure you go pick up this TCP/IP Illustrated so you don't have to remember what offset certain headers or certain fields are in the DNS packet. You don't let someone else remember that stuff. So these are just a few ideas. I'm going to publish my whole list of books at some point. Some blogs to read: Data-Driven Security, Bob Rudis's blog. He's at Rapid7 now. My blog, the Open DNS Security Labs are still publishing a lot of really good stuff, and a lot of the way that it's being published is based off some of this methodology that I've shown. And with that, we're almost at the top of the hour. Does anyone have any questions at all? Everyone still awake? Yes? The slides will be posted, probably tonight. And if I know Adrian, the presentation will be uploaded in like... Damn Canadians. Ruining everything. Yeah, so most of the presentation will be uploaded. The slides will be uploaded. But yeah, if you don't want to ask questions here, by all means, reach out to me on Twitter, email. I'm going to be here all day today and tomorrow. So yeah, come find me. And with that, I'll leave you to the next speaker. Or, yeah.